सो वेलकम बैक अगेन। नेक्स्ट क्वेश्चन की ओर बढ़ते हैं विच इज कॉमन डिविजर्स। सो इस क्वेश्चन में हमें n इंटीजर्स दिए गए हैं एंड हमें जीसीडी निकालना है किसी भी दो डिफरेंट नंबर्स का। सो देखते हैं कि इस प्रॉब्लम को कैसे सॉल्व करेंगे। सो लेट अस सपोज हमें अरे गिवन है 3, 7, 9, 12, 18 एंड 24। तो हम ब्रूट फोर्स अप्रोच में क्या सोच सकते हैं कि हम दो फॉर लूप्स लगाएंगे और हर एक इटरेशन में मैक्सिमम जीसीडी अपडेट करेंगे। मैक्स जीसीडी क्या होगा? मैक्स जीसीडी विल बी इक्वल टू द मैक्सिमम ऑफ करंट जीसीडी, मैक्सिमम ऑफ मैक्स जीसीडी वी हैव टिल नाउ एंड जीसीडी ऑफ array of I and array of j। ये होगा। बट ब्रूट फोर्स अप्रोच की टाइम कॉम्प्लेक्सिटी कितनी है? O ऑफ n स्क्वायर, जो हमें टीएल ही देगा बिकॉज n की रेंज है 1 से 2 से 10⁵। तो हमें एक ऐसी अप्रोच चाहिए जिसकी टाइम कॉम्प्लेक्सिटी n log n या फिर उससे कम हो। तो देखते हैं कि हम कैसे सॉल्व करेंगे। सो लेट अस सपोज यू आर गिवन टू नंबर्स विच आर 18 एंड 24। तो हम ये कैसे पता चलेंगे कि इन दोनों का जीसीडी कितना है? जीसीडी निकालने के लिए हम पहले इनके डिविजर्स निकालेंगे। 18 के डिविजर्स क्या क्या है? 1, 2, 3, 6, 9 एंड 18। सिमिलरली 24 के डिविजर्स क्या है? 1, 2, 3, 4, 6, 8, 12 and 24. So GCD is nothing but the highest number which is divisors of both number. So इन दोनों में मैक्सिमम नंबर जो सिमिलर है वो जीसीडी हो जाएगा। So 6 मैक्सिमम नंबर जो दोनों में प्रेजेंट है is nothing but GCD of 18 and 24. So see what you are saying that the maximum number which is divisors of any of the two number is nothing but GCD. Similarly, if suppose we are having another number like 12, so divisors of 12 are 1, 2, 3, 4, 6 and 12. So here also if we see 6 is present in these two numbers. This is the largest divisors which is present in these two numbers. So 6 will be GCD, right? So what we can see that any number which is present and which is occurring more than once will be a GCD. I can give you one more example. Like if we see if 4 is a GCD or not, we can see that 4 is occurring two times in the divisors of 12 and in the divisors of 24. So 4 can be GCD, but we want to find the maximum GCD. So the answer for this particular test case of the three numbers, the answer will be 6. Now how we can find it? Suppose we want to find whether 6 is the maximum GCD or not. So for finding it, we know that 6 will occur at the multiples, like 6 can be GCD of what numbers? 6 can be GCD of the numbers which are having 6 in its divisors. So number of numbers which are having 6 in divisors are 6, 12, 18. All the multiples of 6 will have 6 as the divisors, right? So these are the numbers which will have 6 as the divisors in their divisors, right? So we know that these are the numbers which are having 6 in their divisors. Now among these we will find how many numbers actually we have in the given array. So we have this 24 and we have this 12, right? So we have two numbers which are having 6 as the divisors, and we have concluded that any divisors which is occurring more than once can be a GCD. So if the frequency of the divisors which is occurring more than one, so this will be the GCD, correct? So our approach will be from I equal to 10 to the power 6 to 1. For every divisors, we will find the multiples of it. So I will be very firstly the for loop will go from I equal to 10 to the power 6 to 1, and the second for loop will go from j equal to I. J should be less than 10 to the power 6, and j will be go incremented by I. So it will go for every multiples of I. Like if we are calculating for this number 6, it will go through every multiple of 6 and find how many numbers we are having in the given array which is having 6 as a divisors. So we will be incrementing the frequency of, or we will be having a counter, and we will increment our counter if that number is present, if this particular j is present in our array. How we can find if j is array? We can simply make a map and store the frequency of every number. And if you find the complexity of this algorithm, complexity will be order of n log n. Now you will say that why it is not n square? Because we are having two loops. Actually, you have also solved this problem before in the mathematics section only. Because see, for I is equal to 10 to the power 6, the inner loop will only run for one time. For I equal to 10 to the power 6 minus 1 also, the inner loop will run one time. Now, if you go on finding the summation of this AP, it will be maximum of n log n. We have the derivation of this, but it is no longer needed. You only need to know that the complexity is n log n at max for this algorithm, where we are going through the every multiple of j. You have also seen this particular algorithm in the sieve of erythrosis, which has complexity of n log n. So whenever we are going each multiple of I, then the inner loop has complexity of log n and upper loop has complexity of n. So overall time complexity will be n log n. So likewise, you can solve this problem. I will show you the code how I have implemented this. So I have taken n as input and the integers corresponding to it, and created a frequency vector which will be storing the number of uh, frequency of each number we are having. And for every divisors from I equal to 10 to the power 6 to 1, we are calculating the count will be storing the number of numbers we are having which has I as the divisors. So for every multiple of I, we are finding how many numbers are there which is having I as its divisors, right? If it is having, if there are more than one number which is having I as the divisors, then we will be outputting that divisor, right? So this was the solution of this problem. I hope you get it. Like, it was pretty clear enough from the explanation. If you have any doubt still, you can ask me in the comment section. I will try to answer it. So thank you so much.